taking that the radii are equal, we're trying to solve for these guys, and we know that it's a right triangle. Hopefully by this point you've realized that maybe if we use the Pythagorean theorem, we could solve for this missing side length. So the idea is a squared plus b squared equals c squared. So we have x squared plus x squared equals 10 squared. That's 2x squared equals 100. Adding these two guys together is 2x squared. That means that x squared is equal to 50, which means that x is equal to the square root of 50. I'm going to go ahead and leave it in the square root of 50. A perfect square does come out, but I'm going to save that for later for my final answer to be fully simplified. I'll leave it in the unsimplified way until I'm completely done with my answer. Okay, so now I've solved for the radius, which opens up all of the other options for us in terms of what we need in order to solve for this. So again, we're solving for that shaded region. We just found out that x is the square root of 50. And then taking that, we see that there's one radius here and one radius here, so they combine to be 2 times the square root of 50 for that length right there. Using all of that information, we're now going to apply it to our area formula. Area of the rectangle is going to be length times width. So that's going to end up being the square root of 50 times 2 times the square root of 50 minus 1/2 times the area of a circle, where the area of a circle is pi r squared. So we've got pi, and then our radius is the square root of 50 squared. We're going to go ahead and multiply these out. It does say the exact area, which means we're not going to find any decimals. So for instance, pi, we have to leave as pi. We can't simplify it out. So make sure to leave it in terms of pi, which means it's going to behave kind of like a variable. And then besides that, we want to keep everything that is not a perfect square inside of the square root. We'll do this one together, and then you can do 4 on your own. So the square root of 50 times 2 times the square root of 50 is going to be 2 times, and the square root of 50 times the square root of 50 is 50 minus 1/2. The square root of 50 squared is 50, and then we have pi at the end there. So that ends up being 100 minus 25 pi. And then these guys cannot combine because 100 does not have pi in it. We can't multiply pi out because then it wouldn't be exact anymore. So this is our exact answer. It does not tell us units, so we won't give units back. Okay, it says determine the exact area of the shaded region. Hard to tell, but this is actually the shaded region that's going on. Oh, that is actually the shaded region of what is going on in problem number 4. A few things before I let you loose on this problem. This whole distance is the square root of 20. So if I wanted to represent one of these distances, I would do 1/2 times the square root of 20. All right, see if you can figure this out on your own. So I'm going to first put together a little composite figure formula. And that composite figure formula is going to be the area of the shaded region is equal to the area of, hopefully you noticed the square was what was fully on the outside, and then minus, we've got 4 quarters of a circle here. So all 4 of them combine to be one big circle. So it actually is minus the area of the circle. All right, so the area of the square is going to be one of those side lengths squared, or the side length times the side length, but since they're the same, it's that thing squared. So the square root of 20 squared minus, and then the area of the circle is going to be pi times the radius, which is 1/2 times the square root of 20 squared. Okay, square root of 20 squared is 20 minus. That squared piece has to multiply to the half as well as the square root of 20. 1/2 squared is 1/4. It's 1 squared over 2 squared, so that's 1/4 times square root of 20 squared is 20 times pi. One more simplification gives us that 1/4 times 20 is 5, so it's 20 minus 5 pi is our exact answer here. Okay, very last problem. I would like for you to do this on your own. I want you to calculate the area of this triangle. The first thing you should always do when you're working through a problem is write out your formula. Well, the area for a triangle, the formula area that we know right now, there is another one that you're going to learn maybe this year, maybe next year. But 1/2 times base times height. So we have 1/2, our base is the square root of 10, and our height is 2 over the square root of 5. I'm going to put this all over 1. And that's going to end up being the square root of 2 times the square root of 10 over 2 times the square root of 5. Those 2's cancel out, and we're left with the square root of 10 over the square root of 5. And I want you to remember that that just means the whole square root of 10 over 5, right? Just like 1/2 squared is equal to 1 squared over 2 squared. You can also go backwards from that. If there's something happening in the top and the bottom, and that's the only thing that's going on, you can then make it happen to the whole fraction there. So then that's going to be the square root of 2. Again, no units, so we just leave it like that.